So what is this actually? What we are discussing here? I mean, as I mentioned yesterday, we were like, what is the angular momentum, right? So angular momentum, we already know that it's, as you know this, L is equal to, what is L? It's R cross, R cross M into omega cross R. What is this? Let me explain. Or sometimes we can write R cross V, R cross V, right? So MVR, R cross V, where V is omega cross R. We already know that M into R cross omega cross R. So this is the actually angular momentum, but we already discussed the angular momentum in terms of, you can also write like MVR, but this here there is no vector. Since the angular momentum is a vector, you should write it as a vector form, M into V cross R. So this is a vector. Okay. So angular momentum, what is angular momentum? It's a it's a, cross product
M.
of V and R and multiplied by mass. And when what is actually when it play very important role in the motion. So whenever you have the rotational motion, angular momentum play very important role, a very important role. Whereas a linear motion, uh, P linear momentum play very important role. So P is equal to mv, right? So here you can see that linear momentum P is mv, whereas V is given as omega cross V, omega cross R. We already discussed that V is equal to omega cross R. Since V is a vector, so this cross product of omega angular velocity and linear radial vector is also vector. So I just substituted this. And as you know that angular momentum is also vector, I'm writing like this, mv cross r, but again r cross I just put outside, v again I have substituted here. So r cross m omega cross r. So this is another way of representing angular momentum. We also talk about the force equation dp by dt. This is for linear motion, right? And we also mentioned last class, torque is equal to dl by dt. This is like a rotational motion. You have this because when the torque is equal to 0, angular momentum is equal to constant. When force is equal to 0, linear momentum is conserved. These are the things we learn in intermediate itself. So now things about here. So what is tensor? Tensor is the word. We derive the momentum of inertia. Tensor from the fundamental definitions of angular momentum and the by working out the double cross product. This is the double cross product. Right. Here, what is T? T is the, what is T beta? T is actually kinetic energy equation. So we know that T is equal to 1 by 2 mv square, right?
Half mv square.
But I can write it this as a m into v dot to v, right? V is the vector
Yes, sir.
quantity, v dot v. So when I express, we already know that v is equal to,
Omega into R.
yes,
Omega
correct.
cross R.
Very good. Omega cross R. So I
R.
just substituted here. So what I did is here, just someone can add this guy. I split into V dot V. I separated MV separately. Then one of the V
Yes,
I'm
sir.
writing here omega cross R. Okay. And when I substitute that, I'm going to get, here mass is actually constant. It's not a vector. Here there are three vectors, omega, R, V. These three vectors are there. So what I am going to write here is omega R cross MV.
L.
Okay.
L.
So, but this will give, what is this will
L
give?
is equal to mvr.
Correct. Angular momentum.
Angular momentum.
So this quantity is equal to the L vector. So I get a 1 by 2 omega L. Actually, should
Okay.
write it like a dot product because kinetic energy is a scalar quantity. Okay. And here also there should be dot. Scalar product always the dot product. dot product of two vectors. This is a very important. See how, like, very someone asked, like, what is the relation between the angular momentum L, angular velocity omega, and kinetic energy T. And this is the relation that explain what T is 1 by 2 omega L. So here you can also write it, what is this? L is equal to angular momentum equal I omega. L is equal to I omega.
Omega.
So how we got this one? How we got this one? So you need to prove it. So L is equal to MVR, right? So how do we
Yes.
get this one? Tell me. There is a way.
V is
M
equal to
R and V is what is V?
omega into omega
Very
cross R.
good. So if I consider like a scalar, I can write it as a omega r. So this is going to be mr square omega, right?
Yes, sir.
Mr square is the I, moment of inertia. So I can get this equation too, I omega. So there is a many ways to convert from, these are a very, all these relations are very important to remember. So I got this one also.
Sir,
Now,
R square is equal to IR, sir.
yes, L is equal to I omega, we got it right. So when I
Yes, sir.
substitute here, what I'm going to get? So
Omega
this
square
is
है तो
equal to 1 by 2 omega
omega square
I omega. So I'm going to get
square रहा sir.
1 by 2 I omega square, right?
Yes, sir.
So this is also one way of telling 1 by 2 I omega square, like mv square beta. You know that kinetic energy 1 by 2 mv square.
1 by 2 mv square.
Now tell me m is equal to I. So these two are, kind of same. So this is a linear motion. We represent mass, and when you have a rotation motion, mass is changing. When mass is changing, uh, when mass is distributing around the axis, we can tell that moment of inertia. And this is the m I both are kind of same linear and rotatory motion. So V and omega same. V is the linear velocity, omega is the angular velocity. So you also need to remember these equations. Okay? Is it clear?
Clear, sir.
So very important, remember Nana, all these, note down all these equations. Very, very important. Sometimes they're going to ask 4 marks questions. You don't need to just, need to remember all this stuff. That's it. You don't need specific notes for this. Don't, some people are asking, please give me notes. What is this? No, if they ask relation between the angular velocity and angular momentum, you have to copy from here itself. That's it. I don't need to write like intermediate question, obtain the relation between the omega LT and రాయాల్సిన అవసరం లేదు beta. But you just need to, understand and write it, whatever material we have it. Okay, I'm gonna send you reference book definitely. I'm going to post soft copy of mechanics. I'm trying a best book actually, so that will help a lot for your future career, not for the semester exam. Semester exam ki na material నీకు full marks వచ్చేస్తాయి. For these semester exams, you will get full marks if you write this. For the
Okay.
competitive exams like IIT, JOM, central universities, for that you definitely need some reference book. Definitely whatever we teach also it helps, but you need to go little depth. Okay. uh, I think let me, I don't want to yeah, it's already more than 1 hour we started, but yeah, just since I don't have the final year. Do you have a math class today?
Yes, sir.
Yes, sir.
Sir,
What time?
Math class ఉంది.
I don't tell lies. I can see that schedule. Do you have it really?
Yes, sir.
What time?
9:20, sir.
9:20, sir.
9:20. Now time is right.
Yes, sir. Math class is there, sir.
Okay.
No, is over, sir.
So it's fine. One more essay question is there. I'm going to talk to next, precision, spinning top, and Euler equation. This is the long answer question they're asking. So tomorrow I'm going to finish this Euler equations and symmetric top. Then finally, tomorrow class is the last class. I mean, for this unit. So 2 units are over. 2 long answers are completed around like a 2 to 4 marks are completed. If you have any doubt, we'll discuss. Okay. So tomorrow, don't miss it. Another long answer is going to be tomorrow. We already like variable mass equation, rocket equation itself a long answer, but out of 2 long answer, 1 question will be there. Okay. Any doubts?
No doubt.
No doubt.
I think most of you finished the attendance, right?
Yes, sir.
Yes, sir.
So attendance link I already posted. Hope you received.
సార్ ఒకసారి పోస్ట్ చేయాలా సార్ మళ్ళీ?
Yeah, sure, Nana. Yeah, I just posted. Complete it. That's important. When you come for that hall ticket or internal exams, we're gonna check the attendance. Right. Okay, Nana. Have a wonderful day. Thank you.
సార్ సెమిస్టర్ 1 ఎగ్జామ్ ఎప్పుడు ఉంది సార్?
సెమిస్టర్ ఎగ్జామ్ మేబీ ఫిబ్రవరిలో కానీ మార్చ్ ఫస్ట్ వీక్ లో కానీ ఉండొచ్చు. సెమిస్టర్ 2 జూన్ లోకి వెళ్ళిపోవచ్చు. సమ్మర్ లో హాలిడేస్ ఉండవు. వి డోంట్ హ్యావ్ హాలిడేస్ ఫర్ దిస్ ఇయర్.